train is down. We still got 4 more to go. Day one, getting it sorted out, trying to figure out what accessories need added. These need to get installed. I think they can clip on here. I want to send them down that chase way, but I need to add some 4-wire to the end to get them from the back of that chase up and over here. If we do labels, I do think we should do a nice big one out here on the suite number, and also maybe a little guy to go out here. Ah, shit, it's raining.
This thermostat needs some love.
All right, let's talk commissioning real fast. So step 1, walk up and you're gonna pull your control panel, your gas panel, both blower doors, and our burner compartment. And then the burner compartment door, we're gonna put inside the unit. Over here, we're gonna check, before anything's lit up, we're gonna check that our motor key is set, that all of our bolts and nuts on our moving pieces are good. We're gonna turn our gas valve on, open up our cap on our adjustment port, turn on our gas. So if it does leak, we have a few minutes to kind of smell it before we fire it. I like to disconnect the thermostat, especially on this building where I don't know what's connected and what's not. And then we're gonna go in for voltage, make sure that that's right. But before we flip the switch, we're gonna check that our transformer's tapped right and look for any loose wires in this cabinet. All right, step 2 on commissioning, the economizer, right? So we're getting ready to power this on. First, we want to make sure that our jumper's in place, we're connected. This one's kind of tight. I don't know what happened. These needed plugged back in. And then on this batch, I don't know why they're doing this. 6 is test mode, okay? This needs to get moved back to number 1. If you start it up like this, it'll be fine, but it's gonna open the outside air damper 100% and close the return air 100%. So you're gonna get weird numbers if you don't put your economizer into the right mode. All right, commissioning, step 3, right? We're on our voltmeter on volts. Ideally, you always wanna take volts through one hand. This is a 480 volt system, right? So we're gonna see, we should be coming in on top, but verify. And then we're gonna go leg to leg. Leg to leg, and then leg to leg, and then also leg to ground, leg to ground, and my chopstick skills. Leg to ground. Now that we know we have all 3 volt legs, we know that we're within 10% of each other, we're safe to turn this on and energize it into components. All right, we're powered on. So we want to get 2 systems set up. We're going to set our date. It is the 1st. Okay, changed. Fahrenheit, good. This is not a heat pump. This is a conventional system. Change stored. Yep, we have Y1 heat. Fan speed, this is a single speed fan. Airflow 5,000, not correct. This is a 5-ton unit, so our nominal CFM is 2,000. And this matters because it's gonna try to open this damper according to how much air it thinks is going past it. There is no power exhaust or ERV. Occupied, okay? On this, where we have an occupied call from the thermostat, we're looking for an input versus always occupied. And this is going to affect our minimum outside air positions. And if the energy auditor is coming, he's going to make sure that occupied does something. So you need this economizer to be looking for input on occupied. And that's it. But if you don't run through and set this up, the air balancer is going to have a hard time doing his job because this is going to go all wily when he makes an adjustment. But also, don't forget, this needs to be in mode 1, where that'll be all the way open when you power it on. All right, real fast, we're going to check rotation, right? So Reen's real nice about giving us an arrow, right? So we want to see this rotate in that direction, right? So we're going to come over here with our tool that we had ready this whole time, like insulated. We're going to bump our blower contact. You can see, so these are purple, red, black, right? Purple, red, black, that's the compressor, so this is the blower, right? Let it run for a second, and jam over here. And see how it's spinning the correct direction. So now we're safe to run this blower. For our gas brush. So we are jumped out, right? Red to white. Make sure our scale's zeroed. Make sure that our gas valve is on. Now it's very possible on these new construction lines that this needs to be purged of all the air in the line. But we're not going to walk away from this until we know our gas pressure is set right. So if we need to get a couple wrenches and break this open to purge it, we'll do that. But we're going to make sure that we get good flow and set our gas pressure to what's required of us, which on this unit is 3.5 if I can find it. Right here, boom, natural gas, 3.5 inches of water column. Here's something, purging this line, and the roof foam just shot out of this line. Went boom. Yikes. All right, we opened it up, we purged our lines, we got our 2 wrenches, one to back seat, one to drive it open. We're ready to go. We're going again for gas. Now you see these reams, some of them are pretty close, but they almost always need a little bit of help. I like to let this run for just a second to get that blower going. But right now, this is the reason we have this door on, because we're burning off the oil on this heat exchanger, and it's gonna blast out at us here instead of down into the building. Which, if the smoke detectors are live, this will set off the smoke detector, and you're just in for a great day. Woo! Doing everybody a favor. Okay. All right, we already took off our adjustment cap. We're gonna get our screwdriver seated. Okay. And then small turns. This is not a force it situation. Make good contact, make good clean turn. That'll do it. We want our average to be about 3.5. We'll let that run for a second, but then we'll get our cap back on and we're good to go. When I disconnect from heat, I don't like to just shut it off because the heat exchanger needs to cool down. So let's try to do this with one hand. We're gonna pull the wire nut off and just separate these two. It's gonna shut off our burn compartment, but continue to keep our blower motor running so we can cool this heat exchanger down. Because if you don't do that, if you just power it off, you'll hear the heat exchanger like an old house. Creak, crack, creak. There's no need for that. All right, test ports. I like to put one here in our supply side. We're Return side's rough because static pressure doesn't really matter, but temp split it does. We want to be before our filtration. You can kind of see it on the line here. So we can either be up in this corner, which works great for static pressure, but not very accurate for a temp split. To get a temp split, you really want to be in front of this grill for a return or use a wireless probe. And so on this one, we're going to try to go down into this corner, which is like right in here. Remember, this is not a hole, it's a test port. And ideally, only drill a hole the size you have a port or a cap for one. So on these ones, these are 5/16 holes. I drilled them with just a standard step down bit. And these bad boys will plug right back in to make it look nice and pro. All right, this particular sheet wants to see a RPM right here. So we get out the tachometer. It's 12 inches away. That on our sheet, and then we'll do it again with the motor, or that was the motor. All right, we're hooked up, we're watching our pressures. We're gonna go ahead and flip it on, and as long as these go the correct direction, we're good to go. But if those don't go the correct direction, we're gonna need to change our phase rotation. Let's get our door panel in place enough to cover the air. See how our low pressure is coming low and our high pressure is going way up? Okay, my blower came on and took care of that. You stay there, man. Now we're gonna let this run for a minute. We have our superheat and our subcool is coming around, and then this bad boy is in our return air, just to get a more accurate return temperature. At the same time, we're gonna go ahead and do our static pressure readings. And then I also have my temperature probe in the supply so that I can get my delta T. So try to do as many things at a time as possible. All right, as we let this come around, and we wanna let it run for a minute, because if we just document it in the first minute of runtime, we're gonna document issues. So we need to let this run for 10-15 minutes. Which gives us a great opportunity to come through and do our amp readings, right? So we can get our amp draws on the compressor, we can get our amp draws on our blower, we can get our amp draws on our condenser fan motor, all while this is getting time to stabilize. And I guarantee you the guys inside on this job site are pumped. But also you can feel these drain traps are not primed. And I'm also not 100% sure they're deep enough. 3-inch drop. This is almost an inch of static pressure. It's pretty heavy negative. But once these get trapped, then they can condensate. But if it's pulling air in here, it's just gonna roll over and flood the pan. So make sure those traps get primed. All right, we're getting these float switches in. So right now we're just focused on the float switch side, which is this. So I like to feed it down this hole. And then up there, this is the really fun part, is reaching back in there. I got all the screws out on this half. So this bad boy flips up. Boom. And then we can get that into the pan and go from there. All right, let's talk about this safety switch. So this is sitting in the pan. It's got 2 wires coming, well, 4 wires technically. This black set needs to go to power, right? White stripe is neutral, so common on white, red here. Anyway, that's not the big piece, right? So now we have common, okay, and normally closed, right? So unless this pan is flooded, this is just a connected piece. So what we want to do is to turn off the compressor if the pan floods, right? So this back here is our compressor, 24 volt. We're gonna take on that and connect it to our common. Sorry, I can't do this one-handed, right? So now, instead of going directly to the contactor, it's gonna go through this float switch to the normally closed contact. We're gonna put that right back where our low voltage was. So now our compressor is broken through the float switch. If this float switch fails or it needs to be removed from the circuit for whatever reason, this can go right back to there and this unit will be operating no problem. So I pulled this up into here. We're powered up. We have a power, right, and a common nut. Right, this bad boy is feeding red to our thermostat, broken through the smoke. Smoke is powered up in the mix. Green, white, yellow, white, and then back here is occupied. And now I'm pretty sure we need to go in and tell it that it needs to be A and not L, but we'll get to there. I also like to move this fuse up front. It tends to be hidden back there. So if you pull this panel on a service call, you can see right away what's up. There it is. Condensate from the roof for the first time. Day one. Boy. This is just taking four freaking ever. 4 times that we purged this line. There's gas galore. So we might need to figure out our spark rod or something. Oh. Well, there's one way to sort out the fucking spark rod. Goddamn. The second one I found like this. It goes for spark. We've purged it out. It sounds like it sparks, but if you follow our spark tube, let's see if that changes things. Check on all these. Nobody likes to see this. That's an over tightened drain line. See that crack? This is all the way in. Well, at least it's on top. So this is the 3rd one in a row where I've gone to purge that line and had shit hit me. This time it's pipe dope. First time it was foam, second time I'm not sure, it bounced. But that's fun. You can see which ones are leveled, and then you can see which ones are not. So they might have a little bit of an issue with drainage. 1400A. We are engaged for heat. The board says it's trying for heat. Getting a 2-code error, which is inducer motor or pressure switch. No life out of this bad boy. And 50 volts here, so something's not right. Sending voltage to that motor, but moving on. All right, I found it. Doing a little rooting around. This bad boy had no home. And this relay has no drive pin, or whatever you call this. So, let's put that, oh, come on. There, that's that drive pin. Ain't got no light. So I think the problem, because somebody's already been over here. This is Frankie's work, I assume. Somebody cut this out and tried to get it to here to this purple. Purple is a male pin and a female Molex. Right, that hits this red. It's also a male pin. So male pin to male pin, I'm gonna assume that's the issue. That was it. Got those two pins out, wire netted together outside of the junction, and we fired right to life. Boom. That's 100% Ream's deal. I don't imagine anybody on the team is rocking a pin tool. That's pretty cool. That economizer was a liar. It says economizing not available, cool in, cool out, mechanical cool on, but it was doing no such thing. So we got our jumpy jumps back in to get this unit running. I don't really know, but this is not outputting the voltage that it claimed it was. These Jades are gonna be the death of me, but I figured this shit out. So this is calling, power's right, 900B. So I have occupied voltage is being output, right, on Y1 out, but then Y1 out is pin wrong. Y1 out becomes Y2 out, which if you follow it all the way through the piece of shit unit, takes you to a capped wire over yonder. So that is incorrect. All right, 900B, fixed it. That was weird. So this Molex, right, it lives up here. So our Y2 out and Y1 out pins were the incorrect order. So as we went through our Molex, we went yellow to orange and orange to yellow. So now I got them switched up the right way so that we match as we go through. We have the benefit of having multiple examples to go over. But yeah, this lower half was pinned backwards, assuming the upper half of that one is the correct way to do it, which makes this correct and this incorrect. Didn't need to change the pins like I did over there, where I had a male pin and a male pin. This one was just the right pins in the wrong spots. So something to think about. 1400B. So we were going through, we're making sure all of these economizers run right. And that means making sure that the sensor readings are accurate, that we're plugged in right, that our Molex lines are right. And we noticed this bad boy, go ahead and go through some status. Let's get this out of the way. Let's get some nice light on there. Okay, economizing, no. Well, occupied, yes, that's a good sign. Blah, cooling. Mixed air temp, 99. Outdoor temp, dash. So I've done a few different things. We checked the polarity. We have multiple to go against, right? So that unit over there, we went ahead and we got, oh, this is back in here, but we checked this sensor operates well in that Jade. That sensor also does not work in this Jade. I have the same kilo ohms reading on both of my sensors. This Jade is just not engaging or not being able to read a sensor in there. So I think we're gonna go ahead and switch this Jade out. All right, I'm getting close because I can get this to read sometimes. Okay, 1400B. The issue is that it's not reading the outside air. So when it doesn't read the outside air, I got my needle points out. I'm not even gonna try to chopstick it. But between any of the SB terminals, right, when I'm getting no reading, it's 0 volts DC or like 0.002. It knows it's DC, but nothing. Like over there, I get 18 volts DC all day, all the time, reach no problem. Pulling everything off, mainly the only other thing in is this, and I start to get my 18 volts DC back, and we can start to read that. So my first thought was that this Jade bad, but I put a new Jade in and it did the exact same thing. It's not the new Jade. Okay, something else, right? So between these two needle points here, I have full tone, basically, 0.02 ohms. I feel like there should be a little bit more resistance than that, because once it is off for a second, it can start to read the other accessory here. We're on the unit next door. We're doing a little bit of movie magic. Okay. 8.6 microfarads. Right? And that's reading between these two bad boys coming off of this in the same situation, right? So we're back in protocol 1, which this used to say a voltage, now it says addresses or whatever. Protocol 1, we can still read our stuff here, and I have microfarads now on this same plug. On our unit in question, I have 0.02 ohms, and I think it's basically trying to short out the board. It's going into protection mode and stopping putting voltage out on those terminals. So I think the part that's actually bad is this. So how about that? When we pulled off the back of the motor, we found a short between the two wires that led to that pin. Upon further inspection, most of the economizer motors were actually wired incorrectly. So this is the correct way they should be. We had to go through and fix almost all of them. The Molex pin come out that wasn't crimped well. Just checking all the connections since we're wired up funky. So I just so happen to have these bad boys, because I don't carry the million different pin sets that it takes to be ready. So we're just gonna go ahead and bypass the Molex and come right here. So we put test ports in the return, negative pressure return before coil and the supply. We will plug the return and the supply. Pro tip, when you're starting up some units and you don't want to set off the smoke alarm, pull your doors, and this nice side panel becomes your bottom discharge panel. And as we burn this oil off, we're just going to send it out to the roof and not upset anybody inside. Pro tip, HVAC startup tech tip of the day.